Every process, whether you're bottling soda, managing a call center, or even just tracking your own workout routine, it's all filled with data. But a lot of the time, that data just feels like chaos, right? Well, in this explainer, we're going to uncover a really powerful tool for finding the important signals that are hiding in all that noise.
So let me ask you this. When things are going well, is it because your process is genuinely stable and predictable? Or are you just on a good run of luck? It's a really tough question to answer when all you're doing is staring at a spreadsheet of numbers that seem to jump all over the place.
And that's really the heart of the problem. Most processes are just drowning in what we call common cause variation. That's the natural, random noise or jitter that's always going to be there. This makes it incredibly difficult to spot a real problem, or for that matter, a genuine improvement. You end up either overreacting to every little blip, or even worse, you miss a huge shift until it's way too late.
But what if there was a way to manage all this? A way to move from constantly reacting in chaos to actually operating with control? That's our first step here, learning how to find that signal.
The entire goal of what we're talking about today is just this: to separate the signal from the noise. Now the noise, that's that random, predictable variation I just mentioned. The signal, on the other hand, is what we call special cause variation. You can think of it as a flag that something fundamental has changed in your process. Could be for better, could be for worse, but it definitely requires your attention.
So how do we actually do it? Well, the tool is called a control chart, and its power comes from three simple, almost magical lines that basically give your process a voice.
Think of a control chart as a really smart time series graph. It doesn't just plot your data over time, it adds that crucial context. It's like a real-time monitor that shows you exactly how your process is behaving, right here, right now.
So here they are, the three magic lines. You've got the center line, which is just your historical average. Then you have an upper and a lower control limit. Now these are typically set at 3 standard deviations away from that average. You can think of that as the predictable, normal boundary for your process's noise. And here's the crucial part. These lines aren't goals or wishful thinking. They are calculated directly from your own data. They represent the natural, expected behavior of your process as it exists today.
And this brings us to what might be the most critical distinction of all. Control limits are the voice of the process. They tell you what your process is actually capable of. Specification limits, on the other hand, are the voice of the customer. They tell you what you want it to do. Confusing these two is probably the biggest mistake people make. Your process can be perfectly stable and in control, but still not be capable of meeting your customer's specs. And that's a whole different problem to solve.
Okay, this all sounds great in theory, but what does it actually look like in practice? Let's take a look at some real-world wins.
So there was a beverage company struggling with its bottle filling machine. Sometimes it underfilled, sometimes it overfilled. By using a control chart, they were able to finally stabilize the process and cut down on the amount of giveaway product by 1.5 milliliters per bottle. Now that might not sound like a lot, right? But multiply that by millions of bottles and the savings become absolutely enormous.
And hey, it's not just for manufacturing. A hospital used a control chart to track its infection rates. They were able to identify the signals, those special causes, that led to spikes in infections. By digging in and addressing those root causes, they dramatically slashed the infection rate from 8 all the way down to just 2 per 1,000 patient days. I mean, this tool literally saves lives.
And that's really the key. This isn't some long, drawn-out academic exercise. The impact is fast and it's tangible, but, and this is a big but, only when the people on the front lines are trained to understand and, most importantly, to trust what the chart is telling them.
So, you're convinced, but there isn't just one type of control chart. The next step is picking the right tool for your specific data.
But look, the key is to keep it simple. At a high level, your choice really boils down to 2 main types of data. If you're measuring something on a continuous scale, like length, weight, or time, you're going to use a variable chart. If you're counting things, like the number of defective items or the number of customer complaints, then you'll use an attribute chart. That's it. The main thing is just to match the chart to the type of data you've got.
So what actually counts as a signal? Well, the most obvious one is a single data point that falls way outside the upper or lower control limits. But there are more subtle signals too. Things like a long run of points all on one side of the average, or a really clear upward or downward trend. These kinds of patterns are statistically super unlikely to happen just by chance, and they're telling you that something in the process has definitely shifted.
All right, let's bring this all home.
How do you actually get started and make this work in your own world?
The implementation roadmap is actually pretty straightforward. First, you pick your most critical metric, and you gather about 20 to 25 data points to get a baseline. From that data, you calculate your first set of trial limits. You then investigate any weird signals or special causes in that initial data, then you recalculate your final limits and lock them in. But honestly, the most important step is the last one, making this a living tool that you and your team review every single day.
And as you do this, let me give you some insider advice on the 4 big traps to avoid. We've already hammered on number 1, don't confuse control limits with spec limits. Number 2 is just as critical. The whole point of this chart is to teach you when not to react. Don't chase that normal noise. Also, try to avoid recalculating your limits constantly. They should only change when you've made a deliberate fundamental improvement to the process. And finally, don't just automate the signals. Every single signal deserves a disciplined investigation to find the real root cause.
So I'll just leave you with this thought. Right now, in your work, in your projects, even in your personal goals, there is data. And within that data, there's a lot of noise, and there are signals. The real question is, are you equipped to tell the difference? What important messages, what hidden signals could your process be sending you right now